Okay, so I had started recording this yesterday and then it just died. So here's try two. Okay, so we're gonna go ahead and look at significance test for difference of mean now, if you remember. Okay, in the previous lecture we were going over confidence intervals for difference of means where we stated the conditions that we need and the procedure itself along with an example of how to do a confidence interval for difference of means. We also looked at the sampling distribution of the difference between the two sample means. Um, yeah, no, everything is there. And today we're just going to look at the hypothesis test. So really quick, so I don't rewrite this again, this is going to be a two sample t-test, two sample because again, we're getting information from two different samples coming from two different populations. And since we're talking about means, we're going to be working with the t-test. Okay, the conditions, okay, if you notice, they're very similar. Okay, actually the exact same thing as the conditions for a confidence interval for difference of means. Again, you're going to be looking at the conditions for both populations. You have to ensure that you have a random sample. Okay, that the sample size, the first sample size is less than 10% of the first population size. Same thing with the second sample size, less than 10% of the second population size. Okay, that it follows the population follows a normal distribution, or that you can apply the CLT. Okay, or just like when we did a regular one sample t-test, you can also assess the sample data if it does not follow these two conditions. Okay, and again, the last one, very, very important condition is that both samples are independent of each other, and you must state that. Okay, so when it comes to the procedure, same thing as when we did the procedure for a one sample t-test and a one proportion t-test. Okay, you have to state your null and your alternative hypothesis, and you also have to state your population parameters. Okay, and over here I went ahead and wrote how it is that you might see a null hypothesis. Okay, so the null hypothesis typically is saying that there is no difference between the two means. Okay, so very often you'd see mu1 minus mu2 is equal to 0 because if they're the exact same number, of course your difference is going to be 0. Sometimes you also see it as mu1 equal to mu2. Okay, and that's the exact same thing, right? If we add mu2 to both sides, you get that mu1 is equal to mu2, right? They're just saying that these two values are equal, so when you subtract them, it's 0. Same thing with the alternative hypothesis. You can say that the difference of means is positive, right? Greater than 0. The difference of means is not equal to 0, or that the difference of means is less than 0. Now, you might also see it the following way. And this is very helpful because on your calculator, you'll actually see it the way I'm writing it over here in red. Okay, so that's going to be this one. This one over here can be written as mu1 is greater than mu2. This is just saying the first mean is greater than the second mean. Okay, this one is saying that the first mean is not equal to the second mean. And the last one is that the first mean is less than the second mean. And typically in the problem itself, they'll tell you whether you're looking for a positive difference not equal to 0 or a negative difference, okay? And that's going to be in step 1. Step 2 is, of course, your conditions, which are outlined above, all right? And then step 3, we're going to show the work. We're going to name the formula, okay? Name the test, and then we're going to go ahead and proceed with the actual calculator copy, just like we did with confidence intervals. And then we're going to interpret the value, which is when you reject or fail to reject the null hypothesis. Okay, and then you state what evidence you have towards the alternative hypothesis. Okay, so let's go ahead and look at an example as to how to apply this. This is going to be example 3. Again, example 3 is going to be there in the guided practice part of your Google Classroom. Okay, so this is example 3. So for example 3, it says, does increasing the amount, I made a lot of typos, amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. Such observational studies do not establish causation. Remember, you can't determine a cause and effect relationship with observational studies. You need an experiment. So research therefore designed a randomized comparative experiment. Okay. The subjects were 21 healthy men who volunteered to take part in the experiment. They were randomly assigned to 2 groups. Do you remember when we did experimental design? This is where the magic sombrero came into play, and they kind of separated them. Okay, 10 of them received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. Remember that control groups are established for comparison. The experiment was double-blind. That should be a very familiar term. Okay. The response variable is the decrease in systolic, which is the top number, blood pressure for a subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Okay, so if it's a negative number, there was actually an increase. So for example, this person had an increase in systolic blood pressure, while this person had a decrease in systolic blood pressure. And here are the data. Okay, how do the data provide convincing evidence? That a calcium supplement reduced blood pressure more than a placebo on average for subjects like ones in the study. Okay, so let's go ahead and look at what information is important from the actual problem before we actually start tackling the question. In the problem, you have 21 total healthy men who volunteered. Okay, but of course, this isn't going to be our sample size per se. This is the total sample size. People remember when we're establishing a difference, right here you're talking about the calcium supplement and the blood pressure supplement, the calcium one and the placebo one. Okay, those are our two different populations. So let's go ahead and write that down. We're working with those individuals who received calcium and those who received the placebo. These are our two populations essentially. From those that took calcium, okay, it says we had 10. So that means our first sample size, N1, is equal to 10. Right? And then it says a control group of 11 received the placebo pill. So for the placebo, we have N2, the second sample size, which received 11. Okay? Now, typically, we also look for information such as the sample mean, like we did in example 2, and the sample standard deviation, but notice that's not given in this problem. Instead, they give us data. And since they give us data and we have two different groups, we're going to go ahead and put them in the calculator. Okay? And that's going to basically do everything else for us. Now, let's go ahead and establish how we're going to go ahead and write some of these things. Okay, so first step, let's read the question again. Do the data provide convincing evidence that the calcium supplement reduced blood sugar more than a placebo? Okay, this sentence right here goes ahead to tell us how we should write our alternative hypothesis. Okay, so the first part, the null, the alternative, and the statement of parameters. Okay, so let's go ahead and state our null hypothesis. Null hypothesis, HO, right? Let's go ahead and denote the mean, the true mean calcium with mu sub c. You basically want to give these subscripts so you know which mean you're talking about. So you have that the difference between the mean calcium decrease in those who took the calcium supplement and the mean decrease in those that took the placebo supplement, okay, that's why I'm doing P and C, is equal to 0. This is basically saying there is no difference, okay? And then for the alternative hypothesis, okay, we're going to go ahead and write our statement in a way that says calcium supplements reduce blood pressure more than a placebo, okay? Since that's the case, we need a positive difference. We need this number to be bigger than this number. Okay, so that's going to be mu sub c minus mu sub p is greater than 0. Okay, now we also have to go ahead and state what our parameters are. Okay, so we have to tell them mu sub c, okay, is going to be the true mean decrease, okay, the true mean decrease in blood pressure and systolic blood pressure. Okay, and systolic blood pressure, okay, for men in the study, it says healthy men, right? Yeah, healthy men in this study who took the calcium supplement. Okay, and that's going to be our mu sub c. Mu sub p is going to be the same thing, except it's going to be in the men who took the placebo. Okay, so it's going to be the true mean decrease in systolic blood pressure for healthy men in the study. Who took the placebo. Okay, and there we go. That is step one. We establish our ho, our ha, and what our parameters are. Okay, second step is, of course, to check the conditions. Okay, so first condition is, do we have a random sample? And remember, we have to check it for both of the samples that we have. So in this case, okay, you have randomly assigned subjects to groups, so we can actually write subjects are randomly assigned. Okay, subjects were randomly assigned to calcium group. And we can write the same thing for the other one. Subjects are randomly assigned to placebo. Okay, so that is coming straight off of the problem, right? It says they were randomly assigned into two groups. So we have random placement or randomness in this case. Okay, second condition, okay, is the sample size, okay, the 10%. All right, so we can just go ahead and write, well, actually, in this case, you don't really need the 10% condition, just because the subjects in the experiment were not sampled without replacement from a larger population. Okay, but to be on the safe side, in case you ever just don't really know, which is, well, if you typically don't know, you can just be safe and say you do. Okay, so you can just say it's safe to assume there is more than, okay, remember our first sample size is 10. Yeah, 10. So 100 healthy men. Okay, and here it is safe to assume there is more than 110 healthy men. Okay, so there we go. We have our 10% condition, and the last condition is going to go ahead to see the normality. Now, upon reading it, we saw that it didn't state whether it was a normally distributed population. Okay, so we're going to go ahead and it also doesn't apply for the CLT because your first sample is of size 10 and the second sample is of size 11, so the CLT isn't valid here either. So of course, we're going to have to go ahead and type it into our calculator. Okay, so let's go ahead and open up our calculator. And let's see. We're going to go ahead and Control N. I want to clear all of this information. And go down to List and Spreadsheets. Okay, the first one is going to be the calcium. The second one, placebo. Okay, so let me just pull up the data here. Where is it? There we go. All right, so let's go ahead and type this in. First number is 7, -4, 18, 17, -3, -5, 1, 10, 11, and a -2. Okay, so those are our calcium values, and then we just type in our placebo values, which are -1, 12, -1, -3, 3, -5, 5, 2, -11, -1, and -3. Okay, those should be all of our numbers. Hopefully, I shouldn't have missed any, and hopefully I typed them in correctly. Okay, so those are all of our numbers, okay? And then, of course, we need to go ahead and show that there's no extreme skewness or outliers. So go to Data and Statistics. So we click to add a variable. Let's do the placebo, or the calcium one first. Okay, remember, we want to go ahead and see this as a box plot. It's easier to draw. And again, no extreme outliers, no severe skewness, so we're good. Now remember that we can create two box plots in the same graph. So to do that, just hover over where you typed in calcium and type in control menu, and that should give you this particular menu. You want to add an X variable, and of course we're going to add the placebo one. And there we go. We see that the orange one is the placebo, and again you see that there is no extreme skewness or outliers, and same thing with the calcium. So we're just going to go ahead and draw the box plot for each one of these, and I'm going to go ahead and do this while you guys look at my pretty graphs. Remember that it is a graphical display, so title, label, label, tick, tick. Okay. Here in this case, I'm going to go ahead and label one of them calcium, and the other one placebo. Okay, just so you know what I'm drawing. It's probably a better idea. Here it is. Just trying to make it look pretty. Okay, there we go. All right, so I'm gonna go ahead and put my lowest number. Let me see, 0 in the middle. The other one's probably gonna have 4 in the middle. Oh, I drew them backwards, my bad. All right, so then this is gonna be 4, 8, 12, 16, 20, and 0, -4, and -8. The other one is at 0. Okay, and I'm going to go by 4. So 4, 8, 12, 16, -4, -8, -12. All right, so for calcium, did I draw these backwards? I did. Okay. Oops. Let me fix that. Okay. Easy fix. This is calcium, and it's going to be a placebo. Okay. So for the calcium one, we see that our minimum is at -5. So I'm going to go ahead and draw a point here at -5. Okay, quartile 1 is at -3. So here's another point. Okay, the median is at 4. Okay, quartile 3 is at 11. And then your maximum is at 18, which is somewhere over here. Okay, we'll just go ahead and draw our blocks. Remember, it just has to be a pretty little sketch, nothing too fancy. Okay, and then for the placebo, -11 is our minimum. Quartile 1 is at -3. The median is at -1. Okay, quartile 3 is at 3. And then our maximum appears to be at 12. Okay, again, you draw your box. Okay, there we go. So we just write there appears to be no extreme outliers or skewness in each box plot. Okay, so we can go ahead and continue. All right, and of course the last condition is both groups are independent of one another. Okay, all right, and they're independent of one another because of the random assignment. Okay, so we have our conditions in place. Now we can go ahead and do our test. So remember, for step 3, you're going to go ahead and show your work, but you have to name the test first. So in this case, we have 2 samples, so it's going to be a 2 sample. Okay, and since we're talking about means, we're going to be talking t-test. So 2 sample t-test. Okay, 2 sample t-test. So let's go ahead and go to the calculator and do our 2 sample t-test. Okay, so let's go to a calculator page. You don't want to delete any of the previous documents on your calculator just because you're going to need the data that you typed in. Okay, so we go to menu, statistics, okay, and we're doing stats tests. And of course, we're doing a two-sample t-test. Okay, there's a two proportion z-test, but remember, the z-test is for when you have the standard deviation of the population for means, which we don't have. Okay, and the t-test is for when we don't have that standard deviation. Okay, so then it asks us how we want to input our information, and we actually have data, we don't have stats. Click OK. Okay, list 1 is basically going to ask you which one you want to have first, the calcium or the placebo. Remember that in our problem, we define mu1 to be the calcium, the first population to be the calcium. So we're going to type in calcium over here. Okay, list 2 is going to be the placebo. Frequency stays the same. Okay, now our alternative hypothesis, if you remember, oops, over here, was that calcium has to be greater than the placebo one. So when you type in your alternative hypothesis, you need that the first population is greater than the second population. So mu1 is greater than mu2, and it's not pooled. Pooled is just when they're equal. The population means are equal. Okay, you're always going to type in no. So click OK, and there we have all of our information. Okay, so in case you forget the name of the test, remember you can just copy this down, two-sample t-test. Okay, and we're going to copy down only certain information. We're going to copy the t-value, the p-value, and the degrees of freedom. Okay, so let's go ahead and type this information down. Okay, actually let's write down all of it, and then we're going to go ahead and type in the mean, standard deviations, and so on and so forth. Okay, so on our paper, oops, wrong paper, minimize that. Okay, so on our paper, we're going to go ahead and do the following. Okay, so after we name our test, we're going to go ahead and write our t-value. So t is equal to 1.60372. Remember, this is going to be your standardized test statistic, your t-value. Okay, and this is now we have the p-value, which is just a probability. The p-value is going to be 0.06442. Okay, 0.06442. And then we're going to go ahead and type in our degree, or write in our degrees of freedom. Again, there's a really complicated formula for degrees of freedom. You don't need it. The calculator computes it for you. So 15.5905. Okay, and then let's go ahead and write our sample means. Okay, the sample mean for calcium is going to be 5. The sample mean for the placebo is going to be negative 0.2727. Okay, standard deviation for calcium is going to be, what is it? Okay, 8.74325. And the sample standard deviation for the placebo is going to be 5.90069. Okay, let me see any other important information. We already have the sample sizes, so we don't need to worry about that. Okay, now, if you remember, what's going on here is that if you're looking at a t-distribution, right, so it's going to be t-distribution with degrees of freedom equal to what we got for 15.5905. Okay, this is 0. You got a p-value, okay, a t-value of 1.60 standard deviations above the mean. So it's going to be over here, 1.60372. And the probability of you getting such a difference, okay, a difference where the calcium is greater than the placebo, okay, is going to be that p-value that we have, which is going to be 0.06442. So this is the probability of you getting such a value. Okay, assuming the null hypothesis is true. Okay. Well, that is 5. Never mind. Okay, so let's go ahead and continue. There's your p-value. Okay, let me make sure I didn't forget anything. I'm sleep deprived, guys. I'm sorry. All right, we're good. Excellent. Okay, so then we continue. All right, so now what we have is, okay, now we have to go ahead and see if we're going to reject or fail to reject the null hypothesis. Remember, you never accept, okay, the how you go ahead and reject or fail to reject, and you compare it to the p-value. Now, if you look at the problem, there is no p-value, okay, that was stated. So since there's no p-value that was stated, I'm not a p-value, significance level that was stated, you go ahead and choose whichever significance level you want. Typically, it's standard to choose a significance level of 0.05. So let's go ahead and choose a significance level of 0.05. I'm red and red. Alpha is equal to 0.05, and we're going to compare p-value to our alpha. Okay, so it's going to be 0.06442 and compare to 0.05. And if you notice, okay, it's going to be greater than 0.005. So, okay, remember, if the p-value is low, you reject the hoe. In this case, the p-value is not lower than the significance level, so we don't reject. We fail to reject. So our conclusion, our fourth step, is going to be as follows. Since your p-value is equal to 0.06442 is greater than 0.05, which is your significance level, okay, we fail to reject the null hypothesis. Okay, you fail to reject the null hypothesis. Okay, so that means the experiment, or there is no convincing evidence okay, and if you look at the problem, we can just rewrite this last part. Okay, there is no convincing evidence that a calcium supplement reduced blood pressure reduced blood pressure more than a placebo on average. Okay, on average. For subjects like one in the study. Like the ones in the study, not this one. Like the one in this study. Okay? All right. And there we go. That's the hypothesis test. All right, now let's go ahead and look at the second part, which is to interpret the p-value you got an A in the context of the experiment. All right, now before I do that, let me go ahead and backtrack a little bit what this 1.60537 means. Okay, now we have two sample means, right? We have 5 and we have negative 0.2727. Okay, our null hypothesis takes the difference of these two means. Okay, so we have 5 minus negative 0.2727, which is going to be equal to 5.2727. Okay, the probability of us getting this particular value, all right, with this, by the way, this particular value is associated to this t-value. All right, the probability of us getting this particular difference, given that the mean is true, is going to be 0.06442. Okay, so that's exactly what we're going to go ahead and write in part B. Okay, so it's going to be assuming the null hypothesis, which is basically that mu sub c minus mu sub p is equal to 0, right, is true. Okay, there is a 0.06, what was the p-value? 0.06442 probability of getting a difference of, which is what we got, right, of 5.2727, right, 5.2727, okay, between the group that took the calcium, well, in systolic blood pressure. Okay, between the group that took the calcium and the group that took the placebo. And there we go.